Well, everybody, it's Jarn again. Recently we've been screwing around in Warcraft, but today it's study time, so sorry if you were expecting another Warcraft map review, but not this time. Um, Today we're going to be going over some limits, because I got final exam not tomorrow, but the day after tomorrow, so I got to make sure I knew it myself, and I figured the best way to do it is make a noob guide for how to do limits. So, well, to do that, I'm gonna get some. Let's get some limits up here. Okay, so first thing before you try anything else with solving a limit, you should see if you can. Let's make a notepad. 1. Can I use the substitution property? Question mark. Because we don't know if we can really use it until well, you might just know it intuitively if you've done enough limits, but assuming you don't know it intuitively, you have to try it first. And now, what is substitution property? Basically, it's what it sounds like. If you have, let's say, like you have the limit of, I don't know, x. This is something really stupid that honestly, you're lucky if you get this on a question this easy on an exam. You probably won't get a question this easy on your final exam, but x plus, not the and sign, 7, there we go. I was holding down shift for some reason. Limit of x plus 7 as x goes to, I don't know, 5. The direct substitution property says just put 5 in for x and see what you get. And this will not always work, but as long as you, well, this is an example that does work, I'll tell you that much. So 5 plus 7, because we're putting this 5 in for this x right here. So 5 plus 7, that is obviously going to be equal to 12. So that, and the answer you'd write on your exam is the limit of x plus 7 as x goes to 5 would be equal to 12. That's the answer you'd put on the exam. Now honestly, you're lucky if you get questions this easy on your exam, because my calculus professor hasn't given us questions this easy. I don't think he even gave us questions this easy when he first introduced us to limits, honestly. So you're pretty lucky if you get a limit question this easy. No. More than likely, you will not get questions that the substitution property will work on, and if you do, you might get like 1. They're most likely not gonna give you ones that easy. So, what happens if the substitution property fails? Well, first we need an example that it's actually going to fail in. Obviously, I'm not gonna just say, oh, you're just gonna have to know, but no, I'm gonna actually give you an example where it fails. So, limit of 1 divided by x as x goes to 0. Now this you cannot just, this right here you cannot easily just solve, because, well, let's try it. 1 divided by 0. Oh, guess what? That doesn't fucking work. Oh, I never would have guessed. So, oh yeah, I'm sorry. Let me just do this really quick. So, when this happens, you're going to have to probably think of it graphically. And I happen to know mostly what this graph looks like. Basically, as x gets bigger, y gets smaller, y being f of x. So, when you get one like this, you're going to have to think of it graphically, which means either you're going to have to just remember what the graph looks like, or you're going to have to draw your own. So let's say we don't fucking remember what this graph looks like, because I didn't study enough to remember just from remembering, so, but you can figure it out. Okay? I mean, if nothing else, you can always, plot points. If you're really that desperate, you can always plot points to figure out what the graph looks like. like this. Alright, so 1 over x is our... Oops. I hate paint. I probably shouldn't even be using paint, but... Alright, so I happen to know that as... Basically, as x gets bigger, y is going to become smaller and smaller and smaller, because, you know, when x is 1, y is 1. When x is 2, y is 1/2. It just keeps getting littler and littler and littler, so it's going to do something like that as it gets smaller and smaller. Well, maybe. Yeah. Okay, that works, I guess. I don't know. Sorry, I'm getting a little particular. And now the thing is, as x gets... Okay, as x gets smaller and smaller, not negative smaller, just like you know, like 1/2 and that stuff, y is going to start to grow. So like if it's 1/2, it's going to be 1 over 1/2, which is equal to 2. So y will just keep growing up like this. Something like that, except not quite like that, because Paint really is not a math program. You might be wondering, well, why the fuck are you using Paint? Well, because as I've said before, I use free software, so there you go. And the other thing to keep in mind is there's going to be another one of these, like over there, if you know what I'm saying, but like turned over. I don't know if that makes any sense. Like it's going to be like a negative version of this. Like maybe I should just draw it, you know what? Basically, it's going to look something like that, except negative. Alright. So actually, this probably can't just go to 0, because this probably won't make any sense. It probably has to go to 0 from the left or the right, or else it's not really making any sense. So we just made it coming from the positive side. And because that's the case, you know, 1 divided by 0 doesn't work, but we can intuitively see that from this, that f of x, which is also y, if you're going to think of algebraically, but f of x, which equals 1 divided by x, or if you want to think of it as y equals 1 divided by x, you'll be able to see that as it gets closer to 0, it's blowing up to positive infinity, because it's never quite getting, you know what I'm saying, it's never quite getting to that, it's never going to stop growing. It's just going to keep going up forever to some point that we don't really feel like drawing, because we'd be drawing it forever. Literally, you could keep drawing y equals 1 over x for the rest of your life if you wanted to, but don't do that, because what's the point? So from this, we can see that this limit is going to plus infinity, which normally the infinity symbol you'd want to draw on your test. You wouldn't want to write infinity. You probably could, but I think your math teacher will respond better to this right here. This like sideways 8 looking thing. Let me try again. There, right there. That's probably what your math teacher wants to see. Let me see if I can make it better like this. There. Transparent. Something like that. That's probably the best I can make it in shitty ass paint. You're going to want to draw it, but when you actually draw it, you're not going to draw 2 circles. That's a stupid way to draw it. You're going to draw like a sideways 8. Like that. There, that looks a little better. So this is what you do if you can think of it graphically really easily. Now, let's say you can't think of it graphically that easily. You might be able to do something else to make it easier on yourself. Like let's take one of the ones from my why am I being retarded? My exam review. This one right here. This run right here. I did it earlier. I can tell you, I would not want to graph this one personally. There's a much easier way to do it, and I'm going to show you guys that easier way to do it. So way number 2 was graphing if it's easy enough. 3 is going to be a method called, I'm not sure if I'm spelling this right, but I know it looks something like it's called L'Hôpital's rule, but it looks like low L hospital. But it's a rule you can use if you have a certain special situation. Like, I could not use it on the situation of 1 over x, to my knowledge at least. Maybe you can, but from what I know, you cannot use it. Alright, from what I know, you cannot use it. But from what I do know, with the special situation, and this special situation actually happens quite a bit, at least on the examples I've been on my homework, it's happened quite a bit. It's been very helpful. L'Hôpital's rule is probably one of the most important things you're going to learn about limits, as far as, unless if you really think you can do all the limits with direct substitution, which you can't. So, well, anyways, to the point, enough rambling. I'm going to show you this first one right here, where my mouse is moving around at. You see it right here, right here, right here? Yeah. Limit is x goes to 1 of x squared minus 1 over x squared minus x. Let's get this imported into Paint here, because I'm such a pro using Paint, right? That's like what all the geniuses use for their math, right? I bet Albert Einstein would do his math problems on Paint. Whoops. Where did that go? Okay, there we are. Sorry about that. I do not know why. I misclicked somewhere. Alright. We're gonna crop this and zoom in on it a little bit. Maybe. Control plus. What? Does this thing not know what Control plus? I really do hate Paint. There we go. I don't know why it does not know what Control plus is. But yeah, this limit right here. So you notice, if you plug in 1, watch what's going to happen. You're going to get 1 squared minus 1 over 1 squared minus 1 again, because you can see it's basically the same thing. Here, you know what? Let me not just make you guys trust me. Let me actually type it out for you. Okay, so you're gonna get, let's down this font a little bit more. There we go. Maybe that's too much. Right here. Okay. Well, you're gonna get 1 squared minus 1, or you know what, let's do this so you guys don't get confused. 1 squared minus 1 all divided by 1 squared minus 1. And looking at this, what this is going to boil down to is, well, you have 1 minus 1 divided by 1 minus 1, which is 0 divided by 0. And in this form, how it is now, this tells us nothing about the limits. So this right here, 0 divided by 0, when you plug in 1 directly, you do not get an answer. You all understand that you can't divide 0 by 0 and get 0. That's not acceptable in mathematics. So limit L'Hopital's. Let me get rid of this. No. Go away. There we go. Well, what L'Hopital's rule tells us is we can take this limit here and we can just say, well, this is the same thing as the limit as x goes to 1 of the derivative of this over the derivative of that. So the derivative of the first quantity over the derivative of the bottom quantity. So the top derivative divided by the bottom derivative as the limit goes to 1, or whatever that limit is. It could be 7x, a, whatever. Probably not x, but let's go down here a little bit. Expand. 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 So let's try it. Take the derivative of, so the derivative of the top, I'm sure that's not how you spell derivative, but what was it again? Of x squared minus 1. Now when you derive things, if you don't already know how to derive basic polynomials, just look it up on YouTube, how to derive basic polynomials. I'm sure that there's a tutorial out there. But you'll get 2x, just 2x, because what happens is when you take the derivative of x squared minus 1, you'll get the derivative goes to x squared, and then it goes to minus 1. And when it goes to x squared, you just take the 2 down, put it in front of the x, and 2 minus 1 is 1. So the power becomes 1, and x to the 1 is just x. And then when you take the derivative of just 1, that just goes to 0. So the derivative of the top is 2x. Wow, that turned ugly after I clicked away. This is why I hate paint. It does retarded ass shit. Well, and now I'll take the derivative of the bottom. So, actually, I think the derivative of the bottom is just going to be this with minus 1. But I'm going to actually kind of show you a little bit. So now we take the derivative of x squared minus x, which this is going to go to 2x minus 1, which again, by using the sum rule of differentiation, I bring the derivative through to the x squared and then to the x, and it becomes 2x minus 1. Because when you take the derivative of x squared, you get 2x because of the power minus 1, and then with the x, you bring the 1 power down, and then it's x to the 0 power, which is just 1 times 1, which is 1. So we end up with the limit of 2x divided by, no w's, 2x minus 1 as x goes to 1. And what this limit is going to be is, well, let's see, 2 divided by 2 minus 1, which equals 2 divided by 1, which equals 2. So this limit equals 2, which when you write your answer, you're going to rewrite the original limit, and you're going to want to write, fuck that, let's do this. You're going to want to write equals 2. That's the answer you're going to want to write to your professor. Because you do not want to, just make him look through your work. You even want to circle it like this, because you do not want to make him look through your work. And you know what's even better? If you have a different color, circle it in red or something. Because you do not want to make them look for your work for the answer, because they might just decide they can't find it and give you a 0 or something. You do not want that to happen. So, definitely circle your final answer on the exam. Maybe on your homework, I don't know what your professor does. If it's just participation, Just don't worry about circling the answer. Just do it so you understand it. Don't not do it and just bullshit the answer. We've all done that before, and that does not work out for the test later. So don't do that. Well, I guess you can do whatever the fuck you want, but don't do that if you want to get an okay grade. So there's step 3. If you can't graph it easily, try L'Hopital's rule. Now there's another situation, L'Hopital's rule, I haven't showed you yet. This was the 0 over 0 situation. I'm going to see if I can find one that's going to be infinity over infinity situation. Let's see. That one might be it. Yeah, bring out the 1/2. This one, this is a really good one. You're not only going to have to know the L'Hopital's rule, you're going to have to use the graphing in coordination with L'Hopital's rule. This one's a good one to show you guys. So, yeah, I think I'll get this one. So, no, I don't really want to save that. It's not really relevant enough to save. This time I'm going to crop it so I leave myself some space. See, I'm going to think ahead this time. I'll be honest, I'm a type of person who wings everything, so it's not like I overly planned for this. As I'm sure you can tell, I was just doing my master winging skills, see what I can come up with on the dot. Yes, but that's how you really know it, if you don't have to plan like 10 days in ahead. You know what I'm saying? If you can just wing it and do good, you really know your shit. But for this test, I'm not winging it. I've been studying past couple days, because my last test I did not do so good on because I winged it, and the winging was a failing me. Well, anyways, so before you do anything with this limit, I honestly would simplify it or change it a little bit. So, whoops, why does it keep going to the line tool every fucking time? No. Okay. Have you been seeing that? Like, it's been constantly going back to the line tool. Don't know why that is. Maybe I'm actually clicking on the line tool and I'm saying it's doing something it's not. I don't know. I actually am in college for programming though, so you'd think I'd be good with computers. But the thing about computers that is irrelevant to being good at programming is user interface. Being good at user interface is all about experience with it, and honestly, my experience with Paint was mostly with Windows XP Paint, not with Windows 7 Paint. I kind of stopped using Paint for the most part. I'm just using it for this tutorial because it's not like I really have a much better drawing program. I mean, I have Paint.net. Maybe I should be using that. I don't know, but for some reason, Paint is just the one I opened up. Well, anyways, So, anyways, to the simplifying, I need to stop rambling. You have the ln of x to the... Oh, and by the way, you can write the square root of x. I hope you guys all know this, but you can write the square root of x to the 1/2 power. So we're going to do that. Divided by x squared. Okay, now to the simplification. You can simplify this by... Okay, there's a rule with natural log that you can pull out if it's to a power function, you can pull out the power and put it right in the front. I don't remember what this rule's called. I think it's just called the property of natural logarithms, but it might have another name. I don't know. But you can pull it out like this. And then on the inside, actually, I don't need to put another set of parentheses there. On the inside, you will have just x now. And then that'll be divided by your bottom half, which is still x squared, because I didn't do anything to that. So, okay, now you see this, right? We're all with me. Okay, now this is the part where you'll need a graph. So let's open up another instance of Paint, and I think I have it right here. Actually, let's do this. file, open. Okay, so this is a graph you guys probably want to just remember from using it enough. This is the graph of, ignore the y equals x, that's irrelevant, but this is the graph of, oops, this is the graph of ln, this bottom part right here. Just ignore everything up here to the top left and only look at this line right here. This line right here is the graph of ln of x, the function of ln of x. Alright? You're with me? You're with me? You're with me? I hope you're with me, because I might not be being clear enough. This is the graph of ln of x. And you need this because you need to realize that as x goes to infinity, so, because we have ln of x at the top here, as x goes to infinity, ln of x is going to infinity too. So you need this picture here to tell you that. So this is probably a picture you're going to have to just remember. And it might look like it's like leveling out at some point, but it doesn't level out. It actually keeps going up forever. I've confirmed that with some looking around. And so this goes to infinity, and x squared, as x goes to infinity, just goes to infinity, because it's infinity squared, which is just more infinity. So we have infinity over infinity form. So let me write that out for you guys. We have, yeah, I was clicking that, wasn't I? We have infinity over infinity form. Doesn't that look beautiful how I just drew that? Not really. So we have infinity over infinity form. Now, when you have infinity over infinity form, you can again use L'Hopital's rule. So let's, before we do that actually, when you have a constant in a limit, you can actually pull it out to the front. So let's do that. So let's take this. And I might be like, well, where's the constant? Don't you remember? I just showed you that you can take 1/2 x to the 1/2 and pull it out in front of the natural log. So basically what I'm going to be doing is taking the 1/2 power out to the front of the natural log here, and then because it's a constant, a constant is a number that is unaffected by a variable. It is not a variable in any way. You can just pull it out here like so. So this is 1/2 times the limit as x goes to infinity of the natural log of x over x squared. That's what this is right here. And now that we have that, what we can do is use L'Hopital's rule, which L'Hopital's rule, as I said earlier, says take the derivative of the top and divide by the derivative of the bottom, and take the old limit of what you get when you do that. So we're going to be taking the derivative of ln of x and derivative of x squared, dividing that derivative by that derivative, and then taking limit as x goes to infinity of what our result is. And I'm going to be showing you what that result is right now. So equals, oh, I forgot to, sorry, when I was doing that up there, I forgot to write limit. When you show your work to your professors, you're going to want to actually write limit as x goes to infinity with every line of work, or else they might take off points depending on how picky they are. Some may not care. I don't know. But sometimes they'll let you get away with where you do the work off to the side somewhere else and then you put it back over there for the final answer, but sometimes they don't let you get away with that. So to be on the safe side, ask your professor what they want, because honestly, if you ask them, that's hopefully the best way, unless if they're totally insane, they tell you one thing and then they actually meant something else. You know, I'm sure we've all had professors like that. You know, alright, what do I do for this test? Oh, that sounds great, nice and easy. Oh, I do it for the test. Oh, you mean you didn't like it that way? But you just said you'd like it that way. What the fuck? You know that kind of situation. But anyways, moving on, taking the derivative of the top and the bottom. So this is just going to be limit of you know. Okay, so derivative of the top, that's going to be, okay, so when you take the derivative of a natural log function, what you have to do is take the derivative of the inner quantity, which is x in this case. Write it here. So the derivative of x is 1. Then divide it by the original quantity, which is x in this case. So you're just nice and easy like that. So I'm just doing this so make it easier to see what we're dividing by. So now we have that derivative divided by this derivative of x squared, which is the easy one. This is just your power derivative rule. Just bring down the 2, put the x to the, and then you take it to the power minus 1 of x, which is 2 minus 1, which is 1, which just is x, so you don't have to write that. And that's the limit as x is going to inf. We're just going to say inf for infinity, or you know what I'll do actually? This is what I'll do. I'll draw it in for you guys. Infinity. Oh, that looks terrible. That looks so terrible, even for me, who doesn't usually care. Oh, come on. There we go, that's good enough. Of infinity, there, that's the best I can make it to. So limit, so now we have, from L'Hopital's rule, we have the limit of 1 over x divided by 2x as x goes to infinity. So let's see, is this going to be a viable form for solving? Let's think about this. Well, 1 over x as x goes to infinity. We know that from a, this is going to be another graph thing, I believe. Yeah. So as x goes to, yeah. Oh, sorry about that, guys. I'm back. Just had a little bit of a mental lapse. Turns out I need to simplify this a little bit further. See, this is what happens when you wing stuff. My worst advice to people I used to give them was, you can just wing anything. You'll be fine as long as you remember it, basically how to do it. But that's not true. You always gotta study, or because you never fucking know when you're gonna just be stupid as fuck. Partly it's just because I'm doing more than just doing this. I'm technically talking at the same time. Just okay. Well, to the point. Well, we have limit of 1 divided by x divided by 2x as x goes to, let's just write in there infinity, just like that. Well, the thing is, you need to simplify this a little bit first. So what's going to happen is the x is going to go down to the bottom here. So it's going to end up being 1 over 2x squared. So let's write this limit. What the hell? Why did my font just go up on me? I did not do that. I really hate. Maybe it was the same. I'm just whatever. But it needs to be smaller here. Okay. So limit of 1 divided by 2x squared. I was kind of freaking out there because I did this problem earlier. And I knew how to do it. And all of a sudden I did not know what to do. And I was just like, oh my god. But yeah, I was just having a dumbass moment there as x goes to, let's write her in there, infinity. So now we have it simplified to this, because all we did here was bring the x down from the top to the bottom. And if you don't know why I can do that, you need to look at some algebra tutorials. I'm sorry, I'm not going to explain to you all why you can bring x down to the bottom. It's pretty obvious at this point, I think, but anyways, 1 over 2x squared is the limit we're taking now. And as that goes to infinity, it ends up being 1 over infinity, which equals 0. So, and equals 0. And now why does it equal 0? Well, because if you look at whenever you, well, the stupid way to, you just remember, oh, every time I have a limit with division 1 divided by infinity, it goes to 0. But the way to look at it is, this is basically the same basic equation as 1 over x, alright? So you just think of it as our other little chart. I mean, it's going to look a little different than this, but it's the same basic thing. As x is going to infinity, y is getting littler and littler and littler, and eventually going to 0. Well, apparently, even though it actually goes on, but it actually, the limit, it looks like it's going to 0, and we can conclude from this graph that it, whoops. Fuck you. I guess that's, it is going to 0. Fucking thing did that on me. This is a little bit, yeah. As you can see from, not this, from this graph, as x goes to infinity, y or f of x is going to 0. But this shouldn't be like this. This is, sorry, I accidentally clicked something. I really do hate Microsoft's new version of Paint. If it sucked before, it sucks worse now. Yeah, something like that. That looks a little less retarded, but get off there. Anyways, so that equals 0. So remember, basically what you gotta remember is, if you can't do a direct substitution, see if you can do it with a graph. If you can't do it with the graph alone, try L'Hopital's rule. And then you might still have to use a graph at the end anyways. Because let's be honest, you do not always... There's just some things that you... Well, eventually you'll just remember them, but if you can't remember it, you gotta use the graph. So there's a situation of infinity over infinity with L'Hopital's rule. And I'm really sorry about that lapse of stupidity I had there. So, that's the basics of finding. This has been a noob's guide to finding limits. See you all around. Hope I do good on the exam. Wish me luck.